One type of problem that keeps stumping students are problems relating to speed. In these problems, you usually have information relating to speed, distance, and time. Just note that when we say speed, we're just talking about average speed. Having three different quantities can be confusing, so we're going to give you 6 strategies that will make these questions easier. A lot of these work together, so make sure you watch till the end. Let's go. So the first strategy is to make sure that you know that speed, or average speed, equals distance over time. Using this relationship, you get time equals distance over speed, or distance equals speed times time. These are essential when problem solving. To demonstrate this as well as the rest of our strategies, we'll use 2 problems. Here's the first. A car travels for 2 hours at a certain speed and 3 hours more at a speed 10 kilometers an hour faster than this. If the entire distance traveled is 455 kilometers, find the car's speed in the first 2 hours. Strategy 2 is to draw a diagram. Sometimes this just helps you understand the situation, and this can help you when creating your equations later. Strategy 3 is identify what you're trying to find. Seems obvious, right? But this often is not done well. This also has to do with reading the question carefully. So in this question, we're trying to find the car's speed in the first 2 hours. Be as specific as possible. Strategy 4 is to define variables. So we'll call this speed that we're trying to find, we'll call it x. By doing this, we can create equations and use algebra. If the creating equations and using algebra part is something you need to improve on, check out this video here. Strategy 5 is to summarize all your information. We recommend a table. Let's see what this can look like. So there are 2 parts of the journey, so we'll call them part 1 and part 2. This will be different for every question. On each part of the journey, there's going to be a speed, distance, and time, so we'll put those here. We've let the speed for the first part be x. This is what we're trying to solve for. The speed for the second part must be x plus 10. From the question, 10 kilometers an hour faster. Time is given for the first part, 2 hours. Second part, 3 hours. Now, using distance equals speed times time, for the first part, we get 2x for distance, and for the second part, we get 3 times x plus 10 for distance. Now, let's solve the problem. Strategy 6 is to create an equation and solve it. It is much easier to do this when you have summarized all the information. So we know that the total distance is 455 kilometers. From our diagram, we can also see that we should add the 2 distances. That means 2x plus 3 outside of x plus 10 equals 455. Solving this, we get x equals 85. So the car traveled at 85 kilometers an hour for the first 2 hours. Problem solved. Let's solve one more similar problem, and we want you to look out for these strategies. We'll also give you 2 bonus strategies. Right, Rob can run twice as fast as Bob. By the way, Rob and Bob are not the same person. They start at the same point and run in opposite directions for 40 minutes, and the distance between them is 16 kilometers. How fast does Rob run? Okay, here's a diagram. We're trying to find Rob's speed, and we know he runs twice as fast as Bob. Bonus strategy 1. Be flexible and smart with your algebra. If we called Rob's speed x, then Bob's speed would be half x. Fractions are totally fine, however, it's going to be much easier if there weren't any fractions. So let's call Rob's speed 2x. So Bob's speed is just x. Now, bonus strategy 2. Keep units in mind. The question hasn't told us what units to give the speed, so we'll choose to give it in kilometers per hour. So we want all our units to be in either kilometers or hours. So converting 40 minutes to hours is 2/3 of an hour. Then using distance equals speed times time, Their distances in terms of x are. Now creating an equation, we know that the distance between them is 16 kilometers, so it makes sense to add their distances traveled since they're running in opposite directions. We have 4x on 3 plus 2x on 3 equals 16, 6x on 3 equals 16, 2x equals 16. And since Rob's speed is represented by 2x, we're done. He runs at 16 kilometers per hour. Problem solved. Now we're going to continue this in part 2, where we'll explore 2 more problems, so make sure you check that out. If you found this helpful, please leave us a like and subscribe so we can continue to help people improve and understand mathematics.